Okay, we will continue. So I will share my screen first. Wait a minute. But in Monohari Pashnadi, no, the therapeutic. Outstanding. Okay, so uh, this is your reference book. Okay, digital electronics. I have told you that we will change to these books. Okay, as the reference book. So I have uploaded in the LMS. Okay, so you can refer that one. Okay, so most probably all lectures are based on that book. Okay, the examples and other things. Okay, so I think it will be easy. I think for this course you are not required to refer all downloaded books. Okay, for the exam, if you refer this book, it is only okay. It will be enough. Okay, but if you need more knowledge, you can refer other one also. Okay. So this will be your reference book. Okay, first primary reference book. Okay, so please refer this one. Okay, yeah, this one. Okay, please download and refer this one. And previously we used this one. No? We use this one as the reference book. Okay, John Vocali book. Okay, but we change that one to this reference book. Okay, so I think I still some students are using this book. Okay, that is not there is no any wrong. Okay, it will be okay. I think this book is very good. Okay, but we change to these books because sometime the sequence is somewhat respectively arranged. Okay, so that is why we change to this book. Okay, okay, so this will be the books. Okay, so actually in last lecture and the introduction session we have discussed about flip-flops. Okay, so it will be your 10th one. Okay, actually you no need to refer this chapter because we are not focusing on flip-flops only. Okay, we are focusing on counters and registers. Those are our sequential logic circuits, but the flip-flops is the building blocks for that one. So we need a prior knowledge of flip-flops. Okay, so that is why we are yeah, we just refresh our memory on this. Okay, okay, so uh, so actually in last lecture I discussed very few things. Okay, not much. Okay, if I told you the summary of that lecture, okay, So we have discussed about RS flip-flops and JK flip-flops. Okay. So those are the most basic flip-flops. Okay. So there are many configuration. Okay. So our focus is on clock flip-flops. Okay. That means the flip-flops need the clock to activate. Okay. If the clock is available, flip-flops will be activated. Okay. If the clock is not available, okay, flip-flops in deactive mode. Okay. So okay. Uh, so also I have told you that the circuit symbol is same for JK and RS flip-flops. Only the pin name. For SR flip-flops, this is SNR. In JK flip-flops, it will be JK. Okay, so this will be the circuit symbol. Okay, this will be the circuit symbol for JK flip-flops. Okay, and if it is SR, this will be SNR. Okay, so that is the difference. If it is SR, this will be SNR. Okay, so so this is a clock flip-flops. Okay, JK flip-flops. So you can see that there should be another input. We have to give a clock pulse. Okay, clock pulse train. Actually, we have to give a clock pulse train. Normally, we are giving a clock pulse train. Okay, so it is like this. Okay, the clock pulse will be like this. Okay, so we are giving a pulse train to flip-flops. Okay, okay, and the clock is available. When this clock is available, the flip-flop still in active mode. That means it changed the output. If it is not changed, it is in previous status. Okay. Okay. So I think that is the basic idea you should have. Okay. And you know that there are two types. Okay. Actually, that is based on the input pin. According to the designing, define the bits. Okay, according to define the bits, define the voltage to the bits. Okay, actually that is in line coding techniques. Okay, I think you are not mechatronics students may have knowledge on line coding. It will be okay. Okay, but I want to tell you is that we have two types of flip-flops. Okay, active high input. Okay, actually these are input types. Okay, not the flip-flops types, input types. Okay, and active low flip-flops. Okay, active low. Okay, and so this will be active high one, active high. Okay, and this will be the active low flip-flops, JK flip-flops. Okay, and you can see that active low we have to employ a NOT gate to the pin. Okay, so that is the difference. Okay, active high and active low. Okay, so when you are given a circuit, okay, you should be care about that one. Okay, about this block, about this dot. Okay, if the dot is there, it will be a active low flip-flops, and if the dot is not there, it will be a active high flip-flops. ඒක තේරුණාද? හරි මේ ඒක මතක තියාගන්න ඕන. හරි flip-flops එක අපිට input එක අපි define කරන විදිහත් එක්ක අපිට active high active low කියලා කියන්න පුළුවන් input එක දෙන විදිය. හරි. ඒකට active high නම් flip-flops එකේ මේ dot එක නැහැ. active low නම් dot එක තියෙනවා. හරි. මේ කියන්නේ මෙයා දෙන input එක convert වෙලා යනවා. ඒකනේ idea එක. Okay. So there should be two functional table. For the two cases, there should be two functional cable. Okay. So this will be the active case, active high case. Okay, and this will be the active low case. This will be the active low case. Okay, and you can see that if the clock is 1, okay, clock is 1, you have the transition, okay? And if the clock is 0, okay, if this JK is 1 0 0 1, maybe 0 0 and 1 1, if the clock is 0, the position will not change and you will have the previous output as well, okay? So the output will not change, you will have the previous output, okay? So that is the idea you should have actually, okay? And when we are talking about this clock, there are also two types, okay? This clock, there are also two types, okay? We call them level triggered clock, and what is other one? Can someone tell? Level triggered clock and what is the other one? මොකක්ද අනිත් එක? එකක් level triggered clock එක, and what is the other one?
Edge triggered.
Yeah, very good. Edge triggered. No? It is edge triggered. Okay, edge triggered. Okay, level triggered means the flip-flops state the change. The flip-flops change the states. Okay, at this level. Okay, if the level is 1, okay, if the level is 1, it will change the output according to this. Okay, and if the level is 0, it will not change output. So it will be in the previous mode, previous output. It will have the previous output, same output, QA. Okay, so that is level trigger. The flip-flops is working in according to the levels. Okay, and what is edge trigger? Can someone explain what is edge trigger? Please, someone tell me. If your answer is wrong, it will be okay. Okay. Yeah. Yeah. So that is the answer. Okay. Thank you. But I like if you can talk, okay, because you can improve your skills, no, communication skills using in these classes, okay? Because you need to improve your skills actually, okay? When you are in the campus, okay, you should improve your skills, okay? When you are going to this industry, you can understand the importance, okay? Here you will not understand the importance of that, okay? ඔකට ඉන්ඩස්ට්‍රි එකට ගියපම තමයි ඒක හොඳට තේරෙන්නේ. හරි. ඒ කියන්නේ කතා කරන්න පුළුවන් කට්ටිය, ප්‍රසන්ට් කරන්න පුළුවන් කට්ටිය තමයි ඉස්සරහට යන්නේ. ඉන්ඩස්ට්‍රි එකේ. සමහරට වැඩ පුළුවන් කට්ටිය පල්ලෙහා. හරි. ඔච්චර වැඩ හොඳට පුළුවන් වුණත් ඒ කට්ටිය පල්ලෙහා. හැබැයි ටෝක් දෙන්න පුළුවන් නම් එයා තමයි ඉස්සරහට යන්නේ. හරි. ඉන්ඩස්ට්‍රි එකේ හැටි. මෙකාට්‍රොනික් ඉන්ඩස්ට්‍රි එක ගැන නම් මම එච්චර ගොඩක් දන්නේ නැහැ. මම ටෙලිකොම් ඉන්ඩස්ට්‍රි එකේ හින්දා. එන ටෙලිකොම් ඉන්ඩස්ට්‍රි කියන සම්පූර්ණයෙන්ම අර විදිහට තමයි යන්නේ. හරි. ටෝක් දෙන්න පුළුවන් නම් එයා තමයි මේ ඉස්සරහට යන්නේ. හරි. ඒකින්ද මේ so you can take this as opportunity, okay? ඔකට මේක opportunity එකක් විදිහට ගන්න පුළුවන්. Okay? Then you can try to improve your skills, okay? Actually that is very important, okay? So in this discussion session, actually you also need to talk. මේවා අපි කියන interaction session කියලා. එතකොට මේකෙදි ඔය කට්ටියත් කතා කරන්න. So it will benefit you in two ways actually. Okay? ඒක ඔය කට්ටියට ප්‍රයෝජනයක් වෙනවා විදි දෙකකින්. එකක් තමයි you can get the knowledge on the subject, okay? And you can clear the doubts, okay? And then the other thing is you can improve your knowledge, okay? Communication skills, okay? How you, so maybe sometime we don't know how to ask a question, okay? But you to practice that one, you have to ask the question, okay? So මම කියන්නේ මේක opportunity එකක් විදියට ගන්න. මෙතන කතා කරා කියලා යාළුවෝ විතරනේ ඉන්නව. කට්ටිය යාළුවෝම ඉන්නේ. යාළුවෝ ඉස්සරහා පොඩ්ඩක් ඔය වැරදුනා කියලා එච්චර ලැජ්ජාවකටපත් වෙන්න කාරණයක් නෙවෙයි නේ. දැන් මමත් කතා කරනකොට කොච්චර දේවල් වැරදෙනවද? හරි දැන් සමහරලාට ඔය කට්ටියනේ හදලා දෙන්නේ මට. හරි. ඉතින් ඒවා ලැජ්ජාවට දේවල් නෙවෙයි. ඒවා මිනිසුන්ට එනවා. ඉතින් එක එක මිනිස්සු එක එක විදියනේ. හරි. Okay. So what I want to tell you is that please talk with me, okay? So that you will have the two benefits there. Okay. Okay. So edge triggered. Okay, we are talking about edge triggered. Okay. So the answer is correct actually. Thank you for the answer. Okay. The signal identification or the change in the states happen at the edge. Okay. So if I write the clock pulse here again, okay. So you can see that these are the edges. Okay. These are the edges. And you know that these are rising edge. These are rising edge. Low to high. Okay, it's rise the level from low to high. Okay. And these are what is called? These are falling edge. Okay, rising edge and falling edge. Okay, so this transition happen at this rising and falling edge. Okay, and we can again divide this into two based on the edge nature. There are two types of edge, rising edge and falling edge. Okay, so what is that one? Can anyone tell me, please? Can anyone tell me? What is the two types? The trigger happen at rising edge, and also trigger will happen at falling edge. So there are two names for that.
Positive edge triggered and negative edge triggered.
Yeah. Thank you, Dilakshi. Okay, it is negative edge trigger and positive edge trigger. Okay, positive edge trigger. Okay, so you have two types of triggering. Okay, so it is also very simple. Instead of this clock, okay, if you are given if you are using this edge trigger method, okay, you have to change. We have to change the status at the falling edge or rising edge. Okay, so if it is falling, if it is a positive edge trigger, it happen at the rising edge. Positive edge trigger happen at the rising edge. Okay, positive edge trigger happen at the rising edge. That means this edges. Okay, so when so you can see that instead of clock there should be rising edges. Okay, there should be rising edges like this. Okay, otherwise you will have the same input in other status or other time. Okay, you will have the same status. Okay, so this is for positive edge trigger, and if it's in negative edge trigger, the signal identification or transition happen at falling edge. Okay, this edge. Okay, so instead of this clock, we should have falling edge, this edge. Okay, so that is the idea. Okay, and also I want to tell you another thing. Okay, so you can see that if it is edge trigger circuit, if it is edge trigger flip-flops, we need to identify the edge, no? Okay, if it is edge triggered, okay, we need to identify the edge. Okay, if it is level triggered, no need to identify the edge. You can input the clock directly. Okay, you can input the clock directly. But if you need to need to use a H trigger circuit. Okay, H trigger flip-flops, you need to have a H detection circuit. Okay, so here you can't directly give this clock to the flip-flops. Okay, you have to employ H detection circuit here. Okay, you have to employ H detection circuit here. Detection circuit here. Okay, so it is also a very simple circuit actually. Okay, so if it is positive edge triggered circuit, you have to apply positive edge detection circuit. Okay, it is very simple logic circuit. Okay, I think I have explained it up to some level. Okay, so you can understand the operation by yourself, I hope. Okay, that is very simple. Okay, and if it is a positive edge trigger, you need to have a positive edge detection circuit, and if it is negative edge trigger, you need to have negative edge detection circuit. Okay, negative edge detection circuits. Okay, so normally we need to, if it is a edge triggered circuit, we need to highlight this circuit, no? Positive edge trigger circuit or negative edge trigger circuit. How we denote? How we denote? We just put the triangle at the clock like this. Okay. So if we put the triangle at the clock input, clock port, it will represent the edge detection circuit. Okay. So this represent the edge detection circuits. That means this will be a edge triggered flip-flops. Okay. Get it? I hope you get the idea. Okay. So actually, if you put the triangle only, it will be a positive edge detection circuit or positive edge triggered flip-flops. Okay. For negative edge triggered circuit, you have to put a 0 here. Okay. 0 here or here, I can't remember. Okay. Maybe here. Okay. That means not gate. Okay. You have to use the not gate before the edge detection circuit. Okay. So that is the idea. Okay. So you need, so also you have to check this one also. When the circuit symbol is given, you have to check this one also, whether we have a triangle or not, whether we have a dot or not. Okay, and for the input also you need to check we have a dot or not. If we have a dot, it is active low. If it is if the dot is not available at the input, it will be active high. Okay, and in the same manner for edge triggered circuit. Okay, so I got do you have any question up to this? Actually, this is that is what we have discussed in the last lecture. Okay, so this will be the summary. Okay, do you have any question or unclear points? Okay, actually I no need to remember this function table. Okay, this function table I no need to remember. So I will give one function table. Okay, I will give one function table for the exam. Okay, but you need to know how to apply this. Okay. Okay, so maybe I will give active high only, and you have to convert it to active low. Okay, so it is very simple. You see that in active low case we have a not gate here, so all this bit will inverse, no? Okay, to get this input. Okay, in active low case. Okay, active low case, j will be 0 and k will be 1 to have set. Okay, and j will be in active low case, j will be 1 and k will be 0 to reset. to have 0. Okay. And if j is 1 and k is 1, you will have qn. Okay, previous output. And if the j is 0 and k is 0, you will have the toggle output qn bar, inverse of the previous output. Okay, so that is the idea. Okay. So if I give only one table, you should be able to draw other tables. Okay, so that is the idea. Okay, have you any doubts point, or let's do one example again? Okay. Okay, I have done 2 examples in the lectures, and also I have given uh, given uh, I have given 1 or 2 exercise. Okay, so you can do them and you can practice. Okay, please do that. Okay. Okay, give me a moment. Okay, we will do this one. Okay, this one. Okay, so can you see my Windows Journal screen?
Yes, sir.
Okay, thank you. So you are given these circuits. Okay, it is a JK flip-flops. Okay, then this will be your clock. Okay, this will be your clock pulse. Okay, this will be your clock pulse, and you are asked to find the output here. You are asked to find the waveform here. Okay, waveform here. So can you try to do that by yourself? Please try it by yourself. Take around 15 minutes. විනාඩි 15ක් විතර අරන් මේක පොඩ්ඩක් හදන්න බලන්න. මේ වගේ ඒවා අපි අර ක්ලාස් ඉන්ටරැක්ෂන් සෙෂන් එකේ එහෙමත් කරා. මේක කොහොම අපි අර ඉන්ටරැක්ෂන් සෙෂන් එකේ හරිය. ඒකේ මේ මොකද අර ටේබල් එකේ ප්‍රශ්නයක් නැහැ. අපිට හිතුනේ ඒක අර ඔක්කොම බිඳුව වෙන හින්දා වැරදි කියලා නේ. ඒක බිඳුව නම් ඉන්නේ බිඳුව තමයි ඉතින්. කරන්න දෙයක් නැහැ ඒක හරි. ඔකට ඔන්න ලබන ඉන්ටරැක්ෂන් සෙෂන් එකේ ওই වගේ සර්කිට් එකක් ගහලා බලන්න පුළුවන්. ක්ලොක් එකක් දීලා මොන වගේ වේව් ෆෝම් එකක් ඔසිලොස්කෝප් එක මේ පැත්තට දෙනවා සිග්නල් ජෙනරේටර් එක ගහලා ක්ලොක් එකක් දෙනවා. හරි. ඊළඟට මේ පැත්තට ගහනවා ඔසිලොස්කෝප් එක. ගහලා මෙතන වේව් ෆෝම් එක බලනවා. Okay. You can connect a signal generator here and give a clock pulse, and you can connect oscilloscope here and you can see the waveform. Okay, and you know that oscilloscope have 2 channel, and you can use 1 channel here also. Okay, 1 channel for the input, clock input also. Okay, then you can compare the 2 signal. Okay, okay, so that one you can do in the next class, next interaction session if the labs are free. Okay, I hope the labs will be free on that day. Okay. Okay, please take 15 minutes, and I think if you are not okay, I will give you the table, JK flip-flops table. Okay, JK flip-flops table. So I will give the active high one. Okay, no, I will give you the active low. Okay, I will give you the active low function table, JK flip-flops function table. Okay, so that will be, wait, I have write it somewhere because I can't remember actually. Okay, so I hope this one. Okay, so if the j is 0 and k is 1, so this will be qn plus 1. Okay, present output. This will be 1, 1, 0, will be 0, 1, 1. You will have Qn 0, 0. You will have Qn1. Okay. So this is the function table. Okay. This is a function table, and you have to write the output waveform. Okay, so please take 15 minutes. Okay, maybe up to 11:50. Okay, so you can talk with your friends. Okay, if you are not, okay, you can talk with your friends, and I will remove my headphone and I will not hear your voices. Okay, so you can talk and try to do that one. Please try. No need to send. Okay, you can't send the waveform. So please give a try. Okay. Okay, we will see. So is this active high or active low? One. You need the answer for that one. Is this flip-flops is active high or active low?
Active loss, sir.
Active low. Please again check.
Active high.
Yeah, it should be active high, because if the active low, the input should have the NOT gate. Okay, input should have the NOT gate, not the clock. Okay, so if you have dot in J and K pin, it will be active low. Okay, so in this case we don't have any dot in JK. Okay, so it will be active high. Is that okay? Or any doubts? हाँ? बोला हमारे इधर बच्चे हैं। Okay, I'm sorry. Okay, so it will be active high. Are you clear? Or any issue? Okay, I hope it is clear. Okay, so if you have dot at input, it will be active low, but here we don't have, so it should be active high. Okay, it should be active high. Okay. Okay. Okay, so so okay, tell me that this is a level triggered or edge triggered. This is level triggered or edge triggered. Flip-flops. Can someone tell me, please? Is this level triggered or edge triggered?
Edge triggered, sir.
Yeah, very good. Edge triggered. Okay. Then again, tell me, is it negative or positive edge trigger?
Negative edge.
Yeah, very good. It is negative, no? Because we have a triangle, so that means it represents the edge circuit, edge detection circuit. Okay, so it should be edge triggered, and we have a dot there. Okay, so it should be negative edge detection. Okay, so if it is edge detection, if it is negative edge detection, the transition happen at the falling edge. These edge are the falling edge, no? High to low, high to low. Okay, so this is low to high. Okay, because the waveform is going in this direction. Okay, so here also low, here, high to low. So the transition happened at this edge. Okay, transition happened at this edge. Okay, okay. Now there should be an initial value. Okay, I'm sorry, I forgot to tell you that one. Okay, there should be an initial value. Okay, so let's say that the Q has 0. Initial value is 0. Okay, so here the initial value is 0. Okay, and Q bar should be 1. If the initial value of at 0, if the initial value at Q is 0, the initial value at Q bar should be 1. Okay, because we need to have the inverse. Okay, so this is 1, this is 0, and this is 1. Okay, so you can see that this pin, Q pin, is short circuited to K input. Okay, so Q and K voltages are same, no, because it is short circuited. The voltage level should be same. Okay, so K we should have 0. Okay, K we should have 0. And what about J? So you can see that J is directly connected to the Q bar. J is directly connected to the Q bar. Okay, so it is short circuited actually. So J and Q bar voltage should be same. This port and this port is short circuited, so the voltage should be same. So here you have high voltage, that is 1. Okay, so J should be 1. Okay, is this clear? So if you have any problem, please ask. Okay, is this clear for everyone? If someone has a problem, please tell me, then I will explain it again. Okay, so this will be 1 and this will be 0. Correct? Okay, now okay, so that is the way. So we have J as 1 and K as 0, Q as 0. Let's say that is Qn, and we have to find the next one, no? Next one, the present output. Okay, so we have to find the present output. Okay, so if I take this one, okay, like this. Okay, so you can see that. Okay, now we try to draw the waveform. Okay, at Q. Okay, so I am going to draw the waveform at Q. Okay, so I'm going to draw the waveform at Q. Okay, okay, so you can see that here we have 0, no? Okay, so the position will not change, and the output will be the present output Qn. Okay, so Qn is equal to 0, so you will have 0 here up to this point. Is that clear? ඒක තේරුණාද? ඒ කියන්නේ දැන් මෙයා edge triggered නේ. එතකොට මෙයාගේ transition වෙන්න ඕන edge වල. හරිද? එතකොට දැන් අපි initial value එක 0 නේ Qn වල. Q වල initial value එක 0. හරි? ඒ කියන්නේ අපි දැන් හිතුවොත් එහෙම Qn කියන්නේ 0 කියලා අපිට ඕන Qn + 1 හොයන්න. ඊළඟ status එක ගන්න. හරි? එතකොට මේකෙදි status එක වෙනස් වෙන්නේ නැහැ. මේ level එකේදී status එක වෙනස් වෙන්නේ නැහැ නේ. මේක edge triggered හින්දා. හරි? එතකොට Qn plus also will be 0. So මොකක් හරි ප්‍රශ්නයක් තියෙනවා නම් අහන්න. So if you have any question, please ask. Okay. 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 So at this point, Qn plus also should be 0. So you will have 0 like this. Okay. And now we have find the edge, but it is a rising edge. Okay, this is negative edge triggered. So at this price image, there is no change. The same QN is there. No? So up to this level, QN is so same. No? Okay. So here it should be changed. Okay. So are you okay? Up to this, the QN is 0. So you have QN plus 1 also 0. Is that okay? QN can 0 ne? මෙතෙන්ට එනකල් මෙතන ඉඳන් මෙතෙන්ට එනකල් මේ කියන්නේ මෙතන ඉඳන් මෙතෙන්ට එනකල්ම එයාගේ වෙනසක් වෙන්නේ නැහැ. There is no any difference of the output. Okay. So it should be the same previous output, no? QN. Okay. So QN is 0 and we have 0. ඒක හරි නේද?
Yes, sir.
හරි. Thank you. Okay. දැන් අපි බලමු ඊළඟ එක. So now here at this edge, so you can see that this is a falling edge. Okay. This is a falling edge and there should be a change. Okay. So we will see what's happened. Okay. So now you can see that now the input, so the present output can be changed. Okay. Now what are the input? Input is J is 1, K is 0. Okay, J is 1, K is 0. Okay. Okay. So here I have given the active low function table. Okay. So this is active high flip-flops. Okay. So I have given the active low function table, but our circuit is active high. Okay. So you can't directly use this function table, no? Because this is active low. Okay, is that clear? I hope it is clear. Okay. If you have any problem, please ask. Don't get confusion. Okay. So if this, so this is a active low function table. Okay. So we have to interchange the bit position, bit value. Okay. So if we need to active high, if we convert this to active high, what we have to do? Please someone tell me. You want to convert active low into active high function table. What the things you have to do? මොකක්ද ඔකට කරන්න ඕන? මොනවද ඔකට කරන්න ඕන? Please tell me. I have told it previously.
Change J and K columns.
Yeah. We have to change the bit, no? Yeah. Okay. So here it is 0 and here it is 1. So you have 1 0 here. Okay, not this one. Okay. And now J is 1, so it should be 0. And K is 1, so it should be 1. Okay. And now here J is 0, J is 1, K is 0. So for inactive, if we want to convert it to active high, we have to put it 0. Okay. And if this is 0 and this is 0, okay, it should be 1, no? So both should be 1. Okay. Both should be 1. Okay. So this should be 1 and 1. So this is the function table. Okay. So this will be the function table. Okay. So I will go it again. Okay. I will go it again. So this will be 1 0. This will be 0 1. This will be 0 0, and this will be 1 1. Okay. So this is active high. Okay. So this is active high. 1 0 1 0 1 0. Okay. So this is set. This is reset. This is QN, and this is toggle QN bar. Okay. Okay. Now we have to use this table. Okay. So now you can see that J is 1. J is 1. 0 is 1. Okay. So it is the set status. No? So QN plus 1 should be 1. Correct? So here we have 1. Okay. We have a high level. Okay. So that 1 is up to here. So this is a rising edge. So no any difference happen. So it will goes up to here. No, because this is the falling edge. So the transition again happen at the falling edge. So here it should be a transition. The transition should be there. Okay, and tell me what is that? What is the value here? Take 5 minutes and think. What is the value here? 1 or 0? Please tell me. Use the same logic. First you have to know what are the input value. The input may be changed. Okay, and first you have to check the input value, and then according to the input you have to select the output. So that is the case. Very simple. Please try to do this. Take 5 minutes. This type of things you should be able to do by yourself. Okay. Please try to do this. Tell me the next value, next level. Is it high or low? Is this high or low? Your answer should be high or low. Here, this transition. It is going to low or it is in high. Tell me. Please try. Huh? Okay. Okay. So now you can see that the output of Q is 1. Okay. Output Q, the Q pin should be 1. Okay. So this should be 1. Q is 1 and Q bar should be 0. Okay. So now you can see that Q is connected to K. Okay. Now Q is 1. So the K should be 1. Okay. And if the Q is 1, Q bar should be 0. No? Q එකයි නම් Q bar එක 0 වෙනවා. So Q bar is again connected to the J pin. Okay, short circuited to the J pin. So J also should be 0. Now you can see that at this point. Okay, actually that happened here. Okay, that happened here. This JK value will change at here in this point. Okay, is that clear? තේරෙනවද? මොකක්ද ප්‍රශ්නයක් තියෙනවා නම් අහන්න. මොකද counters අපිට counters හදන්න ගියපම ওই knowledge එක ඕන වෙනවා. We need that knowledge to implement the counters. So you have to understand and you have to clear the doubts, all the doubts at this point. So this is the basic level. Okay. Yeah. Okay. So so that happened, this change happened at this point, because at this point the Q is changed. No, this point, this falling edge, the Q is changed. So according to the Q, the input also change because the output is connected to the input. Okay, so according to that, the output also change. Okay, now outputs change, so input change to 0, 1. Okay. Okay, now we are in 0, 1. The input is status 0, 1, 0 and 1. Okay, so so that is this point. We are in this point. Okay, and if it is 0, 1, now this point At this point, the transition happened, the flip-flops is active. So you can see that if it is 0 and it is 1, it should be in reset mode. Okay. So the output will be 0. So that is the answer. The output is low. So here it is going to low. Okay. And up to here there is nothing happen. And then up to here there is no any change. But again there should be a change here. Okay. So now you can see that at this point again this J and K will be changed. Okay. So tell me at this point what is the J and K value? At this point what is the J and K value? Please tell me. This is very important. Okay. You have to understand. So tell me what is J and K? 0, 1, or 1, 0, or 0, 0, or 1, 1. You have 4 answers. There are 4 combination. Okay. So what is the answer? 0, 0. Yeah, I think I got, sorry.
1 0.
Okay, we will see. Okay, and also I get another one. Okay. We will see whether these are correct or not. So what about others? Okay, we will see. Okay. Okay. So now you can see that now at this point, okay, at this point, now the output is 0. That means this Q pin is 0. No, Q pin is 0. So Q is connected to the K. Okay. So K will be 0. Okay. And if the Q is 0, Q bar should be 1. And Q bar is connected to J. Okay. So J should be 1. Okay. So it will be 1 and 0 again. Okay. So at this point, J is 1 and K is 0. So there is no change happen up to this point. Okay. At this point, what happened? Tell me. What is the level of the Q? Is it high or low? Is that high or low? Yeah, I got the answer. Yeah. What is the answer? Is it high or low? Now you can see that J is 1 and K is 0. Okay. So this point, it is a falling edge. Okay. It is a falling edge. Okay. So there should the flip-flops is active. This flip-flops is active, will be active. Okay. So now you can see that J is 1 and K is 0. J is 1 and K is 0. So the present output will be 1. It is a set condition. So your voltage will be high. Okay. And the high remain up to this level. Okay. Tell me what happened here. So tell me what happened here.
Nothing.
Yeah, nothing happened. Okay. So we will have the same input, same output. Okay. Okay. Now tell me what happened here. Now tell me what happened here. Is that high or low? See the input
Low.
and yeah, okay, we will see. Okay. So what about other? What about other? Is that high or low?
Low.
We will see. Okay, we will see. Now you can see that at this point, J and K will be changed. No? Okay. At this point, J and K will be changed. So we will see what is the J value and K value. Okay. So you know that here Q is 1. Okay. At this point, Q become 1. Okay. Q become 1. Okay. And Q bar becomes 0. So J is connected to the Q bar. So J will be 0. Okay. And K is connected to the Q. So K will be 1. Okay. So we have J0, K1. Okay. So now at this point, again, the transition happened. Okay. Okay. Okay, now the J is 0. Okay. Now the J is 0 and K is 1. Okay. Now at this point again, the flip-flops is in active mode. Okay. So you can see that J is 0 and K is 1. So it is the reset. No, Qn plus 1 will be 0. So here the level will be low. Okay. And what will happen here? Please tell me what will happen here. Is that high or low?
Again high, sir.
Yeah, we will see. It should be high. No? Now it should be high. Yeah. Okay. So you can see that again at this point. Okay, at this point again, the J and K value will be changed. No. Okay. And what is the J value? So you can see that Q is 0. Okay. Q is 0. So K will be 0. Okay. And if the Q is 0, Q bar should be 1 and J should be 1 again. Okay. So now J is 1 and K is 0. So it is in 1, 0. So the Qn plus 1 be 1. Okay. So we have a high. Okay. So it is up to here. So likewise, we will get this kind of waveform. Okay. So, okay, tell me what is the difference between this waveform and this waveform? Tell me it in 2 words. Something is high here and something is low here. Okay, so what is that something?
Frequency.
Yeah, very good. That is the frequency. No? That is the frequency. So what is the frequency actually? Frequency means, the definition is number of cycles per second. Number of cycle per second. Okay. So, so different waveform will have different cycle. Okay. So we can say that this kind of clock, 1 clock cycle means up to here. Okay. So this will be 1 clock cycle actually. This will be 1 clock cycle. Okay. This will be 1 clock cycle. Okay. So the clock cycle means number of cycles per second. Okay. A cycle that is the frequency. Okay. So if I told you that if this cycle time, okay, if this cycle time is 5 nanosecond, 5 nanosecond, what is the frequency? If this is 5 nanosecond, what is the frequency? Please count and tell me. If this cycle, one cycle duration is 5 nanosecond, this is the duration of one cycle. Duration of one cycle. Okay. Duration of one cycle. And what is the frequency? Please tell me the answer. Use a calculator and tell me. So that is very simple actually. Okay. So okay. So you can see that now. So one cycle. Okay. So this is a clock cycle. One active status and one high level and one low level. So that is the one circle, clock circle. Okay. Okay, we will see. I think the answer should be correct. Okay. Okay. So now the time for this is 5 nanosecond. Okay, 5 nanosecond. Okay. Now tell me that. Okay. Now one cycle have 5 nanosecond. Okay. Now frequency, what you want to find? Okay. What you need to find? Okay. So here you can see that for 5 nanosecond, there is one cycle. For 5 nanosecond, there is one cycle. Okay. Now you have to find the number of cycle per second. So how you find? So number of cycle per second, 1 second, should be 1 divided by 5 nanosecond. No? Is that clear? It should be divided by 5 nanosecond. You need to find the one here. You need to convert, you need to map 1 here. So you have to divide it by 5 nanosecond. So that this side also divided by 5 nanosecond. Okay. Is that clear? So this is the number of cycle per second. This is the number of cycle per second. So 1 second we will have 1 by 5. So it will be 0.2. Nano means 10 to the power 9, no? 10 to the power minus 9. So it is come to up. So it will be 10 to the power 9. Okay. So it will be 10 to the power 9. Normally frequency is measured through hertz. Hertz means nothing but 1 by second. That is the hertz, no? Hertz, no? Sorry, it said, no? So this is the hertz. 1 by second. Okay. So you can see that for one cycle, we will have 0.2 into 10 to the power 9 cycles. Okay. So this will be the frequency. Okay. So the frequency is 0.2 into 10 to the power 9 hertz. 10 to the power 9 means giga. So you will have 0.2 gigahertz. Correct? Okay. Is that clear? මේ frequency එක හොයන එකත් ඔයගොල්ලන්ට වැදගත් ඈ. counters වලදී ඒකයි මම මේ කියන්නේ. This is important things to calculate the frequency of a waveform. Okay. You should be able to calculate the frequency or calculate the cycle duration, and you should be able to, if the cycle duration or frequency is given, you should be able to calculate a pulse duration. Okay. So these things you have to do. Okay. Okay. So if anyone have any doubts, you can ask me. Okay. Any confusion or any clarification, you can ask me. Okay, is that okay for everyone? තේරෙන්නේ නැත්නම් අහන්න. හරි? Okay, now tell me. Now tell me. Tell me what is the pulse duration of this waveform? This duration. Tell me this duration from here to here. This is called pulse duration. What is the pulse duration for this waveform?
10 nanoseconds.
Okay, we will see. Maybe correct. I'm not asking the cycle. Okay, this will be the whole cycle. Okay, this will be the whole cycle. I am asking one pulse.
It is also 5 nanoseconds.
Yeah. Malaki, is that clear for you? I think you think that I'm asking this cycle, no? Okay.
Yes, sir. Yes.
Yeah. So I'm asking this one actually, this pulse duration. That is called pulse duration. Okay. So actually that is 5 nanosecond, no? So we know that the frequency should be double. Okay. Frequency should be double. So here we have, okay, first signal, first waveform, we have 0.2 gigahertz frequency. Okay. So the second waveform frequency is double. Okay. So that we should have 0.4 gigahertz. Okay. So if it is 0.4 gigahertz, okay, so that means, what's that means? That means 1 second we have 0.4 giga circle. Okay, giga cycle. Okay, for 1 second we have 0.4 giga cycle. Okay, so if I tell you that again, we have 0.4 into 10 to the power 9 cycle for 1 second. Okay, so this is the number of cycle per 1 second. Okay, so what is the duration of one cycle? So you have to find the one here. Okay, so that you have to divide this by 1.4 into 10 to the power 9. Okay, so you will have what? You will have 1 is divided by 0.4. Okay. 1 is divided by 0.4. So you will have what? Sorry. Sorry, I mistake. What is the mistake I have done? What is the mistake I have done? Yeah, yeah, that is the mistake. Thank you. Okay. So, so here the first signal frequency is 0.2 gigahertz. Okay. This is the first signal frequency. And the second should be half, no, not double. It should be half. Okay. So the frequency should be half. So this should be 0.1. Okay. So I have write the double frequency. So, but the frequency should be half, no? Frequency should be low. It should be half. So the frequency should be 0.5 gigahertz, 0.1 gigahertz. Okay. So now you can use the same logic. Is that clear? Is this clear? I have done a mistake. Okay. The second signal should be half of the first signal, not double. ඒක තේරුණාද හරිද මොනවාරි confusion එකක් තියෙනවා නම් කියන්න if you have any confusion please tell me. Okay. Okay, now we can use the same logic. Okay, so we have for 1 second we have 0.1 gigacycle. 0.1 gigacycle. That means 0.1 into 10 to the power 9 cycle. This number of cycles happen in 1 second. Now you need to find the time for 1 cycle. Time for 1 cycle is 1 second divided by 0.1 into 10 to the power 9. Okay, so you will have 10 to the power minus 9. 1 divided by 0.1, you will have 10. So you will have 10 to the power minus 9. So it should be 10 nanosecond. Okay. So in this case, in the first cycle, the frequency is half, frequency is low, so the duration will be high. Okay. Frequency is half, so the duration will be doubled. Okay. So you have 10 nanosecond for 1 cycle. Okay. 10 nanosecond for 1 cycle. 10 nanosecond for 1 cycle. Okay. 10 nanosecond for 1 cycle. Okay. So this is 1 cycle. Okay. So this is 1 cycle. It is 10 nanosecond. So I have asked the duration of this pulse. So it should be half of 10 nanosecond. No? So it should be 5 nanosecond. Okay. So that is the answer. So are you okay with this this calculation, frequency and the duration calculation? Or do you have any doubts? Do you have any doubt point or confusion or any clarification? Please ask me. Okay, now we have another 20 minutes for now. Okay, so I think now we can start the counters. Okay, now I think we have the knowledge to start the counters. Okay, we have the knowledge to start the counters. Okay, okay, tell me that we have this kind of circuit. We have two JK methods. Okay. I'm sorry, I need to, I think I draw something in the schematic diagram. Oh, yeah, I can do that. Okay. Okay. So we have JK flip-flops. Okay. And it should be like this. Okay. This one. And we have like this. Again, we have another flip-flops. Okay, now we have another flip-flops. Okay, now you have another flip-flops. Okay. Okay, it is also this kind of one. Okay. And this clock is directly connected to here. Okay. And we have this kind of arrangement. Okay. And the same thing we have connected here also. Okay. So again, this will be J and K. Okay. Okay. So this will be Q2 and this will be Q1. Okay. Okay. And the value here is 1. Okay. The given value here is 1. Okay. And we have J here, K here, J here, K here. Okay. 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 Now tell me, so if I given a clock cycle like this, okay. So I am given a clock pulse like this. Okay. So please try to draw the waveform at Q1. Okay. Please try to draw the waveform at Q1 and tell me the frequency. If the frequency, the first signal frequency is F, okay, tell me what is the frequency of the second signal. Okay. So please take some time, takes 10 minutes. Okay, please take 10 minutes and try to find the answer. Okay. And I think you already have that. So this is active high flip-flops, both are active high flip-flops. Okay. And active high function table is 1 0 0 1 0 0 1 1. Okay, 1 0 0 1 0 0 1. Okay, this will be JK. Okay, so it will be 1, it will be 0, it will be Qn, it will be Qn bar. This is set, this is reset, this is Qn, and this is toggle. Okay, so this is the active high function table for JK flip-flops. Okay. So can you try to draw the waveform? Okay. And please tell me the frequency of the second signal, frequency at Q1. Frequency of the signal waveform at Q1. Please try to do this. So tell me if the frequency is F for the first signal, clock signal frequency is F, tell me the frequency of Q1. Please try to do this.
Sir, your mic is off.
Okay, sorry, I'm sorry. Yeah, I got the answer. No? The answer. Okay, feedback. Okay, okay. So, so, so we have to use the same method. Okay, no any difference. Okay, so you can see that I am asking you the output waveform at Q1. Okay, output waveform at Q1. Okay. Okay, Q1. Okay. So you have to worry about this JK flip-flops, no? Okay, you have to worry about this one. So you can say that if you consider this one, you have to do the same thing. Okay, so you can see that first you have to identify this is active high or active low. At a glance, you can see it. This is a active high JK flip-flops. Okay, because the dot is not here. And that after that, you have to identify what is the clock type. Okay, so it is a edge triggered one, and it should be the negative edge triggered one. So at a glance, you have to identify that one also. Okay, so this is a negative edge triggered signal flip-flops. Okay, and now you have to do the same thing. You have to check the JK input, and this is because of this is a negative triggered one. Okay, negative edge triggered one. So you can see that transition happened at these negative edges, the falling edges, at these edges. Okay. So you have to check the value. That is the only thing you have to done. Okay. So you can see that at the initial. So you can see that this is 1. Okay. So J is 1 and K is 1. Okay. Actually, this is somewhat easy. Easier than the previous one. Okay. So the J is 1, K is 1. J is 1, K is 1. Okay. And okay. Okay. J is 1, K is 1. Okay. Let's say that at the initial Q1 is 0. Okay. Qn is 0 at the initial. Okay. So that is the normal initial state. No? Always the output will be 0. Okay. Otherwise, if it is given, sometimes if you are given the Qn is 1, you have to consider that one. If it is not given, you can assume that Qn is 0. Okay. The status is 0. Okay. So now the Q is 0. Okay, Qn is 0 and J is 1, K is 1. Okay, Qn is 0. Okay, and you can see that here up to here there is no difference, and up to this point there is no difference. It is same output Qn 0. Okay, the same output will be there. See, and what happened at this point? Okay, so at this point the status will be changed. Okay, status will be changed. So how it changed? Now you can see that J is 1, K is 1. Okay, so you are in this status, toggle condition. So you can see that if J is 1, K is 1, the output will be Qn bar. Output will be changed to the reverse, not the reverse, to the inverse of Qn. Okay, so previously Qn is 0, not previously, the present Qn is 0. So Qn plus 1, the present output should be 0 bar. So that is 1. Okay, so this should be 1. Is that clear? Is that clear? Okay, so it is going, the 1 status will be remain until next falling edge. Is that clear? Until next falling edge, the level should be remain same. Okay, and if any different happen, it should be happen at this falling edge point. Okay, so again, if any difference happen, it should be happen at here. Okay, so what is the value again? So you can see that here in this case, the Q is not connected with the input. The output is not connected with the input. Okay, so the output value will not affected to the input value. Okay, that is depending on the circuit. මේකදී අපි input එක මේ ගහලා නැහැනේ output එකට. ඒ දෙක join කරලා නැහැනේ. ඒ දෙක short circuit කරලා නැහැ. හරි. එතකොට output එකයි input උයි separate. හරි. They are isolated. Okay, so there is no any impact done by this output to the input. Okay, so but input is given separately. It is always 1. Okay, it is always 1. So whether this is 0 or 1, input will not change. It will be 1 and 1. Correct? Okay, it will be 1 and 1. And at this point again it's changed to, the change should be happen. Now Qn is 1. Okay, now Qn is 1. When the input is 1 and 1, the Qn plus 1 should be toggled. That means it should be Qn bar. That means 1 bar. That means 0. So it will be 0. So it is going up to here. Again, at this point, it will be toggled like this and like this. So you will have a waveform like this. So what is the answer? Okay, so I tell you that the frequency of the first signal is F. Okay, then what is the frequency of this signal? Okay, you can see that this is a 1 cycle. Okay, this is a 1 cycle. Okay. So this is 1 cycle. Okay, and this is the 1 cycle here. So it is going up to here. That means here we have 2 cycles, no? So same duration, in the same duration, second signal you have 1 cycle, but the first signal you have 2 cycles within the same duration. So what can you conclude? This frequency should be half, no? The second frequency should be half. So this should be F by 2. Okay, so please try to do this by yourself. Okay, and I want to find the waveform at Q2 by yourself. Okay, please do that as a homework. Okay, homework. Okay, so you have to find the Q2 waveform, and okay, so this is a homework. Find the waveform at Q2, then find the frequency of the waveform. Okay, if the first wave is F. Okay, so please do this as a homework. Okay, actually what this circuit is a counter circuit. Counter circuit. This is called two pin triple counter. Okay, this is a two pin triple counter. So we will study we study about counters in our next lecture also. Okay, we will go somewhat deeper. Okay, so up to this level you should be able to draw the waveform. Okay, so we will see how this count the clock pulse. Okay, later we can count. These are used to count the items. Okay, so okay, so have you any question? ඔකට මොනවාරි ප්‍රශ්න තියෙනවා නම් අහන්න.